Good morning. Today we are starting about the derivation, that is derive the relation connecting N, U, V and R for the refraction at a spherical surface. Now let us consider the diagram. So now in the diagram we are considering x, y is the spherical surface at the refractive index N1 and N2. This N1 and N2 separate the media of the spherical surface, that is your x and y. Now let us consider O is the luminous object on the principal axis of I and R. I and small r. I means it is the angle of the incident and R is the angle of the refraction. Now from the generalized Snell's law we know that, or we have studied the Snell's law. According to that equation we can write N1 sin I is equal to N2 sin R. N1 and N2 are the two refractive indexes on the spherical surface x and y, sin I and sin R. Now let us consider the angle of the sin I and sin R is very small. If it is very small, we are considering the equation as sin I is equal to R and sin R is equal to R. Now from the equation 1, we know that the value of the sin I and sin R. Sin I is equal to, we are considering I and sin R is equal to R. Therefore, from the equation 1, we are getting the equation N1 I is equal to N2 R. It is, we are considering the equation as a 2. Where I and R is the angle of incidence and the angle of the refraction at the refractive index N1 and N2. Now from the diagram we are considering the alpha, beta and other one will is your gamma. According to this we are getting the equation as that alpha, beta and gamma are the angle at the point of the O, I, capital I and the point is your C. O, I and the point is C. From a triangle we are considering the exterior angle is equal to the sum of the internal opposite angle. We are considering the exterior angle is equal to sum of the internal opposite angle. According to that, we are considering from the triangle OCL. From the triangle, we are considering OCL is equal to, we are considering R. I is angle of the incident. I is equal to alpha plus gamma. From the triangle OCL, we are considering R is equal to alpha plus gamma. Now let us consider equation as 3. Now from the triangle again we are considering CRN. CRN. From the triangle CRN, gamma is equal to, we are considering gamma is equal to R plus beta. R means angle of the incident and plus beta. Or this can be also written as R is equal to gamma minus beta. Consider this equation as a 4. Now from the equation 3 and 4. From the equation 3 and 4 we got the value of the I and R. Angle of incidence and the angle of the refraction. Therefore N1 alpha plus gamma is equal to N2 alpha minus beta. Now from the equation 3 and 4 just we are putting in the equation 2. We know that N1 I is equal to what is that? N2 R. We got the value of I and R. I is equal to alpha plus gamma, R is equal to gamma minus beta. Thus we are putting this equation in the equation 2. Next N1 alpha plus gamma is equal to N2 gamma minus beta. Now open the bracket. N1 alpha plus N1 gamma is equal to N2 gamma minus N2 beta. Therefore N1 alpha plus N2 beta. Take this minus N2 beta this side, we are getting N1 alpha plus N2 beta is equal to N2 gamma minus N1 gamma. Just we are considering the same term one side. Next N1 alpha plus N2 beta is equal to, take gamma, gamma is a common term, take it outside the bracket, gamma into N2 minus N1. Consider this equation as the final. Now from the para-axial case, N is very close to P. Here from the diagram, for the para-axial case, N is very close to your P. Now we are getting the NP is constant. We are considering NP is considered to be a straight line perpendicular to the CP. Now let us consider NP is very close perpendicular to the CP line. This is your perpendicular line to your CP. Next, from the right angle triangle, we are considering NOP. From the right angle triangle, from your figure tan alpha is equal to Pn by Po. Now here tan alpha or tan theta is equal to, it is very small, again we are considering theta. Tan theta is equal to theta for very small angle. Next, tan alpha is equal to Pn by Po. Pn by Po. Then in the same case we are applying for the beta. Beta is equal to Pn by Pi. Pn by Pi for the beta. Next, and gamma is equal to, we are taking Pn by Pc according to the diagram. Next, put alpha, beta and gamma in the equation 5. Consider here equation 5. Here alpha value is there, beta is there and gamma is there. Now from this we are getting the values of your alpha, beta and gamma. Now next, just we are putting the values of alpha, beta and gamma. Here n1 Pn by Po alpha plus n2 Pn by Pi is equal to gamma means Pn by Pc into n2 minus n1. Consider this as equation 6. Now next, consider here Pn is equal to, what is the Pn? Okay, all the Pn get cancelled here or just take it common outside. Next, remaining term n1 Po plus Pn by Pi, n2 Pi. Pn is the common term. Here also Pn is there. This Pn and this Pn get cancelled. The remaining term is n1 by Po plus n2 by Pi is equal to n2 minus n1 by Pc. Consider this as equation 7. Now applying the Cartesian sign convention, we can get or we can find the value of Po is equal to, we are considering minus q according to the Cartesian sign convention. Next, Pi is equal to plus B, Pc is equal to, we are considering plus R. Minus U means it is what? It is the object distance where we are placing it. B means image distance, R means radius of the curvature. Now we got the value of Po, Pi and Pc. Now let us put the values of that. Now from here, Po, Pi, Pc. Put this value in the equation 7. Putting in the equation 7. Now equation 7 is what is there? n1 by Po plus n2 by Pi is equal to n2 minus n1 by Pc. Now we know the value of Po. Minus U is there plus n2 by Pi. Pi means B by n2 by B plus B is equal to, again n2 means what is the value of n2? Just write it as it is, n2 minus n1 divided by Pc is equal to plus R, the radius of the curvature. Or this can be also written as n2 by B minus n1 by U is equal to n2 minus n1 by R. This is the derivation or this is the expression for your n, U, B and R. Now this equation can be also written as n2 by B minus n1 by U is equal to n2 minus n1 by R. This can be expressed in the terms of refractive index of the image space, that is your n2, by B means image distance, minus n1 is there. Refractive index of the object space divided by U means object distance is equal to n2 minus n1. The refractive image of the space minus or the difference of the refractive index of object space by the radius of the curvature. Capital R means it is the radius of the curvature. This can be also written in the terms of this, or this can be also written in this term. This is the expression for the n, U, B and R. Now next we are studying about the length. Length is what? It is the homogeneous medium which is having the two spherical surface, which is having one side and the spherical surface. Length is what? It is an homogeneous medium which is having one surface at the spherical edge. We are calling it as length. Now next we have to study the types of lenses. There are so many types of the lenses. Just we are considering. This we are calling as the biconvex lens. Other one is your biconcave lens. Other plano-convex lens. Next one, plano-concave lens. Next, concave middle it will be thicker. Middle it will be thicker. It will be thicker at the edge, at the point of your edge. Convex length is what? It is the length in the middle. It will be thicker at the edge. Next, other one will be concave length. Concave length. It should be a thinner in the middle part. It is thinner at the middle part. Now, at the edges we are considering. At the edge. Convex length it should be thicker. Concave is what? It should be the thinner. Now next we are studying about the length maker's formula. According to this, we should understand that what is the length maker's formula. Now let us consider the diagram. Again we are considering here length. Okay. Now here we are considering O is the luminous object, AB is the spherical surface. At the point A, B, C, D is the spherical surface we are considering. Here we are considering refractive index should be in the A, the value of that should be 1 both the sides. And with what? It is the refractive index. Next here we are considering UV and another one only V1. Now let us consider according to the equation we got that, or according to the relation of the N, U, V and R, we are getting that equation N2 by V minus N1 by U is equal to N2 minus N1 by R. Now in this case, in the case of the N2 and N1, just we are considering NA is equal to what? NA is equal to what? N1 is equal to N2 is equal to, we are considering the N term. Now N2 is equal to the refractive index of the image space. This is equal to N. Next V means what? It is the image distance. Next N1 again we are considering the refractive index of the object space. U is the object distance and R is the radius of the curvature. Now at the refraction at the base of the ABC. Now we have to study the refraction at the base of the ABC. Now let us consider AB is the spherical length. Okay. O is the luminous object. Again here we have taken I, angle of incidence, R, angle of the refraction. Here we are considering N is equal to the 1 for the image distance. Next R1 is the radius of the curvature. I1 is the incident ray. U is the object distance. V is the image distance. Now according to the diagram we can tell that the refractive index of the object space N1 is equal to, we are considering N, and image space N2 is equal to N. Now or in this case we can also consider N1 is equal to N is equal to 1. Next O is the object distance from the equation 1. Okay, now let us consider here equation 1. In this equation we are considering N2 by V minus N1 by U is equal to N2 minus N1 by R. Just put the value N by V1 minus 1 by U is equal to what? N minus 1. In the case of the radius of the curvature we are considering R1. Therefore the object distance is equal to what we are considering U, and the image distance is equal to V1, and R1 is what? It is the radius of the curvature, and this is just about the reflection at the base of the A, B and C.